Okay, let's tweet this out and put it on the Discord. Okay. Coding and put it here as well. Okay. Cool. Let me just move this away here. I think that should be fine. Okay. It's Tuesday again, so we're doing Advent of Code. I should hit live on Twitch as well. Almost forgot that. Let's see, is it working here? Yeah, that seems to be working. I think this one should go live now as well. Let me see. Yep, looking all good. Great. Good evening, everybody. Welcome. Yeah, another Tuesday, another Advent of Code day. We're up to day 16. We did the last 3 days last week, so that was cool. Not sure how many we can do today. It's been pretty busy. I think by now I'm repeating the same story every week. A bit busy, I'm a bit tired, still not feeling 100%. So I hope that it's all over soon, but yeah, there's still quite a bit of work in the pipeline. But one of my customers had an issue where I made like a live dashboard for all their orders, and it's based off of emails that come in, and their web shop just stopped sending emails. It's not something that I host, so it's not my responsibility, but it means no data for the dashboard. So I coded something in the last few days to fix that and go an alternate route for the data. So it's been busy again. So yeah. So let's see. Let's pull up Advent of Code here. And boom, 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 boom. Close all tabs. That's fine. And we go to Advent of Code 2016. And let's make a new day for day 16. 16. Dragon Checksum. Okay. Just get everything ready. In the meantime, some people have time to filter in if they want. Should probably text Luke. I keep forgetting that. Okay, also done. Okay. So I guess we'll start by reading day 16. Dragon Checksum. You're done scanning this part of the network, but you've left traces of your presence. You need to override some disks with random looking data to cover your tracks and update the local security system with a new checksum for those disks. For the data not to be suspicious, it needs to have certain properties. Purely random data will be detected as tampering. To generate appropriate random data, you'll need to use a modified dragon curve. Okay, sounds spicy. Start with an appropriate initial state, your puzzle input. Then, so long as you don't have enough data to fill the disk, repeat the following steps. Hey Nineberry, thanks for the resub. Appreciate it. Welcome, welcome. Nice, I got a notification now, so that's cool. How have you been? Hope you're doing good. I'm doing actual Advent of Code this time. So I'm just reading day 16 now. Let's see. Start with an appropriate initial state, your puzzle input. Then, so long as you don't have enough data yet to fill the disk, repeat the following steps. Call the data you have at this point A. Make a copy of A. Call this copy B. Reverse the order of all characters in B. In B, replace all instances of 0 with 1 and all 1s with 0. Okay, so you do a binary inverse. Cool. The resulting data is A, then a single, wait. The resulting data is A, then a single 0, then B. Okay, so you have the original one, then a single 0, then the inverse one. Okay. Ninebear says flip-flop was fun. I did this as well, Leslie. Nice, nice. Yeah, I had fun with that. It wasn't too hard. It was a nice like a nice beginner set of challenges. I think you could recommend anybody that's done like a few months of coding, I think should be able to do that and have some fun with it. So yeah, I was also pleasantly surprised by the challenges. So this one, it reverses it, okay. The original, then a 0, and then the inverse, okay, sure. 0 becomes this one, that, and then the inverse. And here we need to do the reverse the order of all characters. Right. So after the initial state here, so then you have the reverse. Yeah, that's interesting. It's like something tells me like do it with binary, like an XOR, but it's the reverse thing is interesting. Okay, repeat these steps until you have enough data to fill the desired disk. Once the data has been generated, you also need to generate a checksum of that data. Calculate the checksum only for the data that fits on the disk, even if you generated more data than that in the previous step. Okay. You also need to calculate the checksum only for data that fits on the disk, even if So now we need to know how much fits on the disk. So you take the thing that you generated and then substring it. So far so good. The checksum for the given data is created by considering each non-overlapping pair of characters in the input data. Okay. If the two characters match 0, 0 or 1, 1, then the next checksum character is a 1. If the characters do not match, the checksum character is a 0. This should produce a new string which is exactly half as long as the original string. Okay, so you do it pairwise. Sure. If the length of the checksum is even, repeat the process until you end up with a checksum with an odd length. Okay, there are so many steps here. For example, suppose we were to fill the disk of length 12. We finally generate a string of at least 12. The first 12 characters are blah. To generate a checksum, consider each pair blah 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 blah. These same, yes. The resulting string has length 6, which is even, so we repeat the process. Okay. You do this one. Sure. This produces checksum 100, which has an odd length, so we stop. Okay, this is like so many steps. Therefore, the checksum for this is 100. Okay. It's a pretty cool, interesting problem set, this one. Hey Luke, welcome, welcome. Combining all of these steps together. Suppose you want to fill a disk of length 20, using initial state of 10,000, because it's too short. We first use the modified dragging curve to make it longer. After one round it becomes this, still too short. After 2 rounds it becomes that, okay, which is enough. Since we only need 20, but we have 23, we get rid of all but the first 20 characters. Checksum, sure. I like this idea. Length this, okay. So let's first do the test, I think. Test put is this, and then we have disk length 20 and this, okay. So we do int disk size is like this, blah. Same here. Disk size is 20. So that one is for the test. So we have the disk size set up. Actually, we can just do test 20, otherwise this. And we can make it const, which is neater. Const int, okay. So we have the disk size there. We should probably implement this. So should have a function just called what did it call it? Dragon curve. Sure. Dragon string dragon curve And I wonder if we should use actual strings or just an array of bools, or I'll just do strings now, but something tells me we should like XOR it. Would make it nicer. Dragon curve. So int initial int length. Actually, we can do this. We can do it multi-step. Actually, we should probably just do it string-wise. Luke says, I'll stop watching at 1945, hosting my own web. Oh yeah, I completely forgot about that. I should get the notification for that anytime soon. Do you have a recording? Or maybe I'll just stop it, the stream then. I forgot about that, I'm sorry. Let's see, string initial, string result is this. So we do initial 0 initial dot reverse. Let's see. That works. So we do while result dot length smaller than disk size. Actually, results. Come on, let's do this. So this is the padding. Luke says the real version is 11. Okay, sorry. I thought I messed something up and I had a conflict there. Good luck on that. Let's see. Pad out the string according to the rules until it's at least long enough. If result length larger disk size, result is result at substring 0, disk size. Okay. Trim if need be. And this is also not correct because we need to invert that. So we can do string reverse and invert string value. Actually, we can just do IEnumerable char for each char c in value that reverse. No, reverse. Yield return c equals 1. Like this. Okay, we should we could optimize this to make sure that we never that we never return more than needed here. So we can do int count is 0 if ++ count larger equal to max break. So now we can exit early. And now we feed in disk size minus 2. Now, this will be 2 times result dot length plus 1 minus disk size, right? This is the max length that we need to return. Cap the results to make sure we don't get more than needed. This could be an infinite loop if there is a bug here, so that should be fine. No, actually this isn't correct. Because what we need is this plus 1. So we need disk size minus this. So this is the space that we have left to fill. Almost messed that up there, so that's good. So this is the padding. Let's do return result. And now we need to do checksum, right? Test is true. Let's set this to 16. Boom, boom. So let's do here console.writeLine. So we do input. Let's see if this works, this part. So I think that should be correct, right? No, it's not. Ah, the trimmed one, yes, okay. So this is the part here. 0, 1, 2, 2, 2, okay. So, okay, that logic is good. First step done. Now we need to pairwise check. And if they match, it was 1, and otherwise it's 0, right? Let's see if they're the same. Yes, if they're the same. Okay, so let's see. And then we do string builder SB is new, just like this. For int I is 0, I smaller disk length, increment I, actually I plus equals 2, because we do it pairwise. If, and now we can just do sb.append to result I equals result I plus 1. Okay. So we do string checksum equals sb.toString, while checksum.length mod2 equals 0. Okay. And we do this thing, and Actually, I should do it in a do while loop. So we do len is result.length. So let's do do, and then this becomes, okay, the while condition is still okay. Like this. Then we do this. We can do this here, sb.clear. And here we actually can just update result. We don't need another update here. So this is the basic loop. We need to keep doing this until it's an odd length. So that is fine. So the test. Okay. Boom, 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 boom. String p1 equals dragon curve input trim. Like this. Okay, same here. Okay, let's see what happens. Okay, that is fine. I don't need this anymore. We saw it worked. So let's do this. Woohoo! First gold star. Okay, nice. It looked very intimidating, but it's not that hard. Okay. Okay. That's a lot longer. This should stabilize, right? It should be no problem now. Yeah, right. So now I can no longer make this a const. Actually, yes. So, that's the first one. Actually, we should be able to just look at this and see if there's something that we can infer from that. So let's grab this into a text box and see if there's any pattern thing that we can put in here. Okay, so yeah, the same blocks alternate, so we can easily do it like that. So if you look here, it's the same blocks. So I'm assuming that this one also repeats in blocks because it's just a bitwise. Oh no, every power of that makes sense. So this one here will then be the same, and then this one is new. No. Okay. So the thing we're noticing is that every even number is just always the initial, this thing here, and then the odd ones repeat like that. So you extend it with a new one every time, I think, right? So you do this, then this, then the new one takes oh yeah, that will be the flip of this. So I need a few more, and then we can figure it out. It should be good. Because what's the length of this? Quick watch. $35. Okay. But I think that's the basic pattern that happens. So I'm gonna actually do the real one here, the second one as well. And I think that's the way it expands. Like you can keep adding a part, and you just have to do a small section that you have to recalculate. And that probably stops scaling at a certain point, but it's fine. Boom. Okay, this one will throw at a certain point, so let me stop it here. Let me see how far I can go back and see if sorry for the flashing light, or is that only on my monitor? It's like a stroboscope. So, really did it not copy? No, I did. Okay, that's fine. That's fine. Okay. Is there an edit word wrap? We don't want word wrapping. Okay. Okay. Let's do this again. Just gonna go stop. Int count is 0, marks is 12. If count larger equal marks, break. Okay. Let me set a breakpoint here. I also still need to put in the actual answer for the first one so that it doesn't break here. So answer P1 equals this, which is fine. Okay, so now let's take this and then break it out. Okay, here. Probably don't need that many, but I want to so let's go back to the start. So here we replace this with A like this. Replace all. Okay, cool. Now this becomes B. Or is it this one? Oh, it's actually just the 1 and 0 flipped every time. So we can do H, B, replace all. Okay, so now you have a visualization of everything that happens. Because this is basically the thing that it duplicates, and I should turn off word wrap here, but and it can't help itself but still word wrap, so I'll just delete this stuff here. But what it does is basically you get A, then A0B, and then the whole thing B0. Because you then flip these. I'm just thinking of how the expansion works. Because you can compress this. I wonder if you can, at what point you can go up and then compress these again. Oh. Because basically that's this AOB is the next thing that repeats, and the A1B so you could do another step if you do like you could do, if I do, you could call this C, and then replace all of those, and then see, that's all of that. So you could do D, and now you're shrinking the problem down until you get to a state where you so I think like the expansion thing you could do, like, you can predict how it expands to a certain point. The only issue that I'm wondering is how the whole checksum thing would then reduce as well. So this is an interesting problem, right? Especially since you can break everything down in smaller blocks. Those sequences also produce something that you can then chunk-wise do. So okay, I think you can see from this, like you can just upgrade and then at a certain point create a new set of simplifications. So there is a way to do this. I'm just now thinking what's the best way. Because if you look at it, like you go from A becomes A0 and then let's call it, it's reversed and flipped, but if you do that 2 times it stays the same, right? Like if you do string test is blah 0101 111 000 110. Test is reverse and invert test. Like this. So we say test equals this. But this should be true, right? So let's run this. Yeah, so every 2 times that you run it, you go back to what it was before. Let me think. I can't go back further here. Let me think. Let's see. Dictionary. Results. I'm just trying to see, like, how can we use this? String alt, actually no, list alt. Alt is this. Results, try get value, result out int ID, results dot add, results dot count plus 1, something like this. So we do alt add, and this would be the ID. ID is results of count plus 1 ID. So we add ID. So this is the basic structure. And this needs to start with like 1 and 0. So we have 0 and 1 in there. These are the separator. At least this is the separator, and this will be, I don't know if we need this yet, but it's fine. So initial representation starts out with this, and then we do no, it starts with this. Then we make a new result. The second part is the inverse flip thing. So string inverse flip is this. And we do the same thing. Inverse flip. And we do alt of add maybe like this, and we also need to add the 0. Results. Something like this. So this is just me building a lookup of the original string. Int alt length is 0. Actually, it would be result of length, like this. So then we do alt length plus equals 1 plus inverse flip dot count. This. That was the reason, because that was a method. That's based off of this. Actually, it's just doubled plus 1. You could just do and now I wonder if we already need to create like an alias for these two together. I'm just thinking how many variations of the same data can occur in the end. It's kind of a tricky thing. I saw the pattern. It's not that complicated, but finding a way to expand it properly is kind of tricky. Because we could now make an alias out of like we could do something like because this one would be new. I should probably also call it like the inverse flip of this should be like the negative of the original, maybe. Yeah. Let's see. Let's say we have string. Let me just call it this thing 1. This becomes 1 a A0 negative A, right? Or 1 becomes 1, 0, negative 1, right? Then we get 0, and then we have the inverse of this thing reversed. So this would then be 1, 1, minus 1, right? And if we do this again, we add a 0, and we need to do this whole thing and then flip everything, and no. This would then be 1, 0, because we need to inverse this one. Let me see. Minus 1, 1, 1, 1, minus 1, right? I think that's correct. So minus 1 becomes minus 1, 1 becomes 0, 1 becomes minus 1, 1 becomes 0 becomes 1, minus 1 becomes 1, 0 becomes 1, 1 becomes minus 1. Okay, so this is the logic that you do. And now the thing is that you can refer to stuff like this every time you make a new combination. You can refer to this as being a new combination. So you could say 2 equals this, right? And this would be negative 2. Because it's a reverse, an inverse of this. Sorry, negative 2. So then you could say I just wonder how we can expand this and if we can make it make sense like this, and how much do you need to actually do this? Because how long was the original thing was this, right? Okay, so let's do blah blah blah. Let's like this. Okay. So okay. So it's 21 times. I mean, just the fact that it saves 34 characters It should be doable, right? So I'm just thinking, like, this is step 1. And if we, for every step, if we create a new alias, it should be fine. Let me just see if I can codify this. Let me think. Void pattern expand. Okay. I wonder if we even need to do that, but I think we can keep going like this, so that you do. So let's see. Int length is input.trim.length. Dictionary. Int, and this will be string format. So we do int normal is format count, and then we do format add. This would be input so this would be normal like this. Then we do int inverse, and this would be inverse, and then we do let's see. So now we have those building blocks. So we can say, okay, step 1 is this. And then we need to do that. And I think for each level, or basically each 2 levels, we just need to do the same. I think we just do each 2 levels. So we start with the first one. So and after this, what you do is just you build not the next level, but the level after that, and we don't care as much because we know, like, string next normal. So this would now become, let me use angle brackets to not mess up with the format. So this would be normal, ID of normal followed by 0, and then we have a reference to inverse, like this. And then we do string next inverse is this, basically. Actually, to be +1 is minus normal, like this. And I don't even need to do that. It's just normal. This is because just minus normal, like this. And then the so the first version, and this would be like a level thing. First level is that. Yeah, we can do it like that. So now we do next normal, next inverse. I think it's like this, right? It's always, yeah, it's the same, except the 0 becomes a 1, because it just takes this one inverted, which becomes a normal, and then this one inverted becomes negative. So like this. So now we can do formats. Now we can do actually normal equals. We should do a level here. Int level is 1. Level. So now we do. Actually, we can just use level. That's way clearer. Like this. So now we can do formats that we can level up. We do formats up for add. This now becomes level, becomes next normal, and minus level becomes next inverse. And basically we keep doing this. So I can do, we just set this up in a nice loop. So do while len smaller than disk size. So you can do normal inverse. Like this, and then we do like this. Inverse is this. I should probably do it like this. Inverse. Something like this. What's the best way to do this? You want to set this up like this. No, you want to do a while loop. So we do len is len times 2 plus 1. Okay. and we check. And we do normal as this. Inverse is this. And we increment here. Cool. We increase the length. So this should give us the patterns for the whole thing. And then we need to expand it all the way down in the end and see how we can repeat that. Because I think we can then just I think for the checksum thing, I think we could just consume one part every time, because you can do two at a time, right? So if you take in the end string, if you have like the end result is level 21 0 minus 21 as the format string, you can just take the first one, break it down, replace that by the 21s, and then take the first one and break that all the way down till you have a non-format string. And then you can take two characters, swap them into one or two, and do the next one as well, and then you can keep taking that. So you can do two blocks of two blocks and then process those two blocks, I think. Or you can just keep expanding until you get one literal, then process that part until you don't have enough, and then keep going. And the thing is, it shrinks in half every time. So there are look-aheads that you can do, but it's it scales. So the checksum thing will also be a challenge that we have to figure out. It's a fun thing though, even though it's giving me a bit of a headache. I thought it might be a quick one, but it's not that easy. So here we should go return actually formats. I think this one is the one that we need then. Like pattern expand. So let's try this. Curious to see what happens. All these random breakpoints. Let's see. Yeah, okay, see? So we have the pattern expand here. So what we could do now is break this down. And I need to make sure that it's actually the correct length. So let me let's do string expand pattern, string pattern. Okay. So let's see. String or char? Let me I will just return character by character. So let's do for int I is 0, I smaller than len is pattern dot length. Okay. What's it complaining about? I didn't do I small len like this. Okay. This one also, this dictionary needs to be global here so that I can access it, or I should do it in a different way, but it's fine. I'll just use it like this right now. So let's do make sure that we clear it every time we run it. If pattern I equals expand pattern. Okay. Let's see. Dun, dun, dun. Pattern index of no int and index is I plus 1, while pattern and index is not equal to closing character. And we do int index is parse int dot parse pattern dot substring I plus 1 and index minus I. Not sure if this one is correct. So if we have this, so this will be, come on, 0, 3. So something like this. Something like this. I think that's correct. We will figure that out in a bit. So then we do yield return. No, I can do for each. And this would be formats index like this. So this one would recursively return until it gets actual characters. And then we can do I equals end index. And then we should skip over it and continue. This will be pretty spicy, so let me just make sure that I can do something like expand format 2 there. So like this, and I do console, the right line, new string, expand pattern, and this would be a simple one. Let's just do 2 here. See if this works. Actually, let's do 2 minus 2. Let's just do a simple one, actually, just 1 minus 1. Let's see if this works. It doesn't work. Nice. Cool. Okay. Set next statement. Oh no, wait, that's not what I did there, right? Okay, let me just see what it does. Step into. Oh, wait, what? Hitting the wrong buttons, nice. Set next statement. What am I doing? Oh, it's the step into is a bit wonky now. Okay. Debug search and field. Okay. Let me just set a breakpoint here and just step through it. I think that's smarter. Okay, so the value here is, wait, what? Pattern expand. Oh no, I need this one, expand pattern. Oh, did I write the correct one? Expand pattern, yes, okay. Okay. So, cool. Oh, I didn't do else yield return pattern I forgot about that one. So now end index is 2 because it's length 1, so that is fine. Okay, so this one actually works as I intended. Okay. So now if you do formats, cool. That's why, never mind. There was a blank line. Okay, let me just stop this. So the code worked, just because my else wasn't there, it didn't show the actual expanded thing. So let me just run the code and it should show up here. Right, cool. So it did this one for level 1. Interesting, is that correct? What was the input string again? Oh yeah, okay. Let me just... I think this is correct. It looks correct to me. So I think this expand works. So that's interesting. So we now have a way to both compress and expand the data. So now my thinking was we need to find a way to then do the checksum thing. And since it was a whole lot of characters here, I wonder if there's a way to simplify that too. The thing is, you can't just keep taking 2 because you have to do it in full runs. And if you haven't done the whole thing, you can't. My idea was, okay, as we expand, we just take 2 pairs of bytes, but that doesn't work because let me think. So we need to then go to the lowest level, I think, and then find a way to also apply this on the formatted string. What I could do is actually, does that matter? I'm just trying to. Has anybody done this, by the way? Am I thinking this? Am I doing this the wrong way? Am I thinking about it too complexly? Because I think I'm on the right track. I'm just now that I've built the whole string. That wasn't the hard part. Well, it's part of the hard part, but basically I can build a format that represents the original string, which is cool. The next trick is to hash it. So now I will need to do like a roll up of the hash as well and find a way to do that. Nineberry said, I simply used my port 1 and it was fast enough. Okay. I think I got an out of memory exception actually when I tried. 3-hour stream for nothing. Well, this was fun. I mean, it's pretty cool what I'm doing. At least I think so. Did I try? I'm not sure. Let me see. I don't know if I even tested it actually. Pattern expand, dragon curve. Do I have console write lines intermediately here? Oh yeah, maybe this was just my issue that I had the right line here. 30 and beyond. Okay, let me just see if this, what happens if I do that, if I just run it. Index was outside the bounds of the array. What am I doing wrong? Dragon curve. Wait. Why is the length odd, actually? Yeah. Let's see. This is the first time, this is the second time. Ah, the result length is... Ah, I had... Never mind, I have this max here. That's why it didn't work. And all of this also didn't make any sense. And this one can just be removed here as well. This one can be removed. It's just this, basically. And it's nice that I do the work twice here. So it's basically this. Okay, let's run this again. Yeah, it just works. Okay. Funny. Woohoo! Okay. Cool. That was funny. Okay. Okay, so string checksum. Calculate checksum. So let's see, and I can do INumerable. Bum. I wonder if I can write this to use the streaming expand of the other thing. Nineberry says, I looked it up and there's some way to do it without actually creating the whole string, but I didn't look into that detail, and most people seem to have solved it the easy way. Yeah. I like the thing that I was building. It was pretty cool. At least I thought it was pretty cool that I managed to do like a compression thing. Nimer says, most people seem to have struggled because they didn't use buffered strings like string builder. Then it takes really... okay, nice. Okay, yeah. I like my... Did you see what I built? I mean, that was pretty cool. I'm just gonna... I wonder if I can do like... Take a while. as long as specified condition is true. Actually, I can do like while pair.count larger 0 dot length equals 2. I think I could do it like this, and then just do this. Something like this. I should probably also save this one to make sure that if and when I change things that it remains working. Like that. Okay. You could probably deduce it in a way from this or something. Well, doesn't matter. I was gonna see if I can do this, calculate checksum. So I can do result, come on, result is calculate checksum result, because string is also an IEnumerable. So let's see if the code still works. Okay, something. Smap says you can use chunk to make the parent code use. Ah, okay, cool. Welcome, by the way, Smap. Did you write the easy approach as simulating the thing or use the same trick to calculate something? Yeah, this is better. For each var pair in this, because this was an infinite loop, I did it the wrong way. So thanks for that suggestion. It's still slow, a lot slower than it was, I think. Ah, because I never update this. Yeah, this only works the first time. And then we have... Like after the first time, we have a string. So I should probably do it differently. This. If result.length mod 2 is 0, return So this is an approach. Smash says, haven't been following along, so I have no idea. I actually wrote something to, like, the logic that it expands into is like this. So if you have the pattern, it's like flipped, reversed and XORed. But if you do that again, you just get the original back. So I wrote something to compress, expand it into a pattern in multiple levels, and it can expand that again. So I wrote sort of a compression engine to express the complex thing in a smaller thing, and then I wrote something that can expand that section by section. So that's what I was fiddling around with. So I was like, if I can do the first step by just iterating through it, and as it grows as it expands, so you don't get a huge memory thing, it doesn't really matter, but it was fun. Just a fun exercise. So I was like, let's see, I think this one should now work. Oh, my P2 is wrong. Interesting. So why did it work for the first one, but not the second one? Basically what I did, I was like, I did this pattern expand of the input. Calculate checksum. That's weird. Why doesn't this work? Try again. Sure. Can do it like this, right? Yeah. Wait, what? Okay. Can just do alt checksum like this, and then Bye, Luke. Good luck on your test run. So for the first part it worked. So I wonder what's wrong for part 2. Ah, this also works. Did I copy the wrong thing again? I've done this before where I just copy the... Yeah. Never mind, I copied the input instead of the answer for my assert thing here. I've done that so many times, it's so annoying. Then I try to make sure that I don't break something, and then the issue is actually my validation part. Okay. Stopwatch dot start. No, timestamp. I'll start. I'm curious to see how fast or slow this is. Var normal and is stopwatch timestamp. And then I want to see if I can use my expand and like my pattern thing to see if that's faster. Probably not, but it's fun to at least try and use some of the code that I wrote, right? Actually, this one, it's the same logic there, so this doesn't make sense at all. It doesn't matter. I can just do result, because this doesn't use the new thing yet, actually. So never mind. Let's run this again, make sure that both parts still work. Sure. Now I want to do part 2 in the new way, where we say part 2 is calculate checksum of expand pattern expand input trim. Right. So this one will take the input, it will make it into the very big thing, then it will deconstruct and yield return character by character to this thing. So I'm curious to see, and this is something that I should time actually. String alt is this. Var regular is this. So let's do this. Var start is stopwatch dot get timestamp. Var stop is stopwatch get timestamp. And then here we have var alt stop stopwatch dot get timestamp. Okay. And here we can say is regular, actually no, alt, console.writeLine. Times that, no, stopwatch get elapsed time, start, stop. Let's put this here. Alt stop. Okay. Curious to see how this one works, if it works even. It should, but boom, index outside the bounds of the array, okay. That's spicy. So is that because there wasn't more data at that time? Okay. Let's see. Split at most size. Okay. So the issue is if I read faster than it can generate it, I will run into this issue. So this doesn't work. So this doesn't guarantee me that I read in chunks. You can finish with less than 2. Sure. But there is a disk length and how do I explain this? Like the length of string that you run this on always is equal length. Always. So you will only start to calculate the checksum of a string that is divisible by 2. Because as soon as it's no longer divisible by 2, you don't run it again. So you always start with a string that's divisible by 2. So this is impossible if it's properly sized up. The thing is, I don't limit my pattern expand here. This one. What size is pair at that point? Just 1 here. But the thing is, I probably don't limit my... there can be 2 things at work here. Either the chunk reading is faster than I expand the data, or will that wait until there is 2 or an end of stream? I'm not sure about that. Maybe it will do always 2 until it's end of stream and then it will return the final one. I'm not so sure about that. The alternative here is that we read more than the max length. So what I can do here is int read is 0. If read plus equals 2 larger equal disk size break, something like this. It's link, it would wait. Okay. I'm not sure if it's like IEnumerable, if this like if it's a blocking wait or not. So I think this would be an option. So the first time this should save it from chunking being irregular. Nope. See, we're not even close to there yet. So I think it actually if pair.count.length is 1, system.threading.thread.sleep 1 second, continue. Let me just set a breakpoint here. I'm just curious to see if it has more data there. Or if it's end of. No, it exits there. Okay, so it has an okay. Interesting. So my expand is not large enough. So the issue is probably that it needs to be double of what it expects. Okay, let's see. So let's remove this part here for now, because I think I need to go one deeper than the thing that it generates. Like it does this, so it should probably just to manually fix this, see if I can test this out. So this should be the final expand then. So let's see if this works. And it's doing more work obviously, and it's clearly not faster, but it works. Cool. No, I didn't actually verify that it works. But at least we know what the issue is there now. So let me just take this. I forgot that I need to do the actual expand for it to exist. Okay, so I can't skip this step here. I just need to make sure that I double the final pattern thing. Cool. Okay, so nice. My code works, but it's 4 times as slow as just doing the regular thing. So just for those who didn't see, I built something that takes the input string and then built like a compressed representation of that string until we hit the desired lengths, right? So the format is basically you have something, you take that one and you get the inverse and bit inverted version of that, and that are your basic building blocks, and from that you can build everything, because if you do that twice, reverse and invert, so the revert and XOR, if you do that twice, you have your original string. So you only need those 2 representations. Now the tricky part is that you put in a 0 as a separator after the original string, which means that in your mirror string that also has that 0 the next time, that 0 will be a 1, but the rest will be somewhat the same. So Smap says, feeling happy with my runtime now. Yeah, nice. So yeah, that's what I was looking at, like how does the data get built up, and then I wrote like an expression or compression algorithm that can take that big string that you want and just reduce it down into a simpler version. And it could write it out as this, just a big string of this with all the zeros and ones with just one level taken out. And then I wrote something that can expand upon that pattern. So it just detects these angle brackets as, hey, there's something that I need to expand. It finds the end index, and then it will just spit out that pattern and try to expand that as well if need be, etc. So I think it was pretty cool to build this, but ultimately now we know it's not faster. And my idea was like you could, because it's in the end it's always the basic building blocks, including the zero. So what I wanted to do is actually go down to that lower level, do the checksum on one of those building blocks, and also use that as a way to further optimize it, because I think you can do something there as well. But in the end, it's not needed as well. Yeah, I didn't optimize for speed coding wise either. I didn't use a span there, but it was fun to see the patterns, build it as a pattern thing, and actually make it work. So that is cool. I think we can just comment this out. Actually, we can just leave it. It's fun. Alternative way of doing it is not faster. Pretty cool though. So, and since we're doing this for fun, I'm happy with what I did. So yeah, nice. I'm gonna take a look at the next day. I'm not sure if I'm gonna do it because I want to get a bit of rest today, but I'm gonna take a quick look at to see how challenging it is, if it's challenging or not. Maybe do a little part now. So yeah. Day 17. Did you, by the way, before I do this, did you like what I did? Was it fun for you to see me build that whole thing? I thought it was pretty cool to do. Let's see, day 17. 2 steps forward. You're trying to access a secure vault protected by a 4x4 grid of small rooms connected by doors. You start in the top left room marked S, and you can access the vault marked V once you reach the bottom right room. Swam says, did my solution make sense? I don't even remember the problem. I don't know, I haven't looked, but let me pull it up. I have it here in the... There's something weird glitching here. Class system string represents text as a sequence of UTF code blocks. I think Visual Studio is having a bit of an issue with something, but oh well. Let's see. Does it need like this new string to char array? Couldn't you target this directly, the span char with this? Let's see, I haven't done day 70, so I'll leave again. I skipped all of the shortest path problems for this year so far. Okay. Couldn't you just do like span char test is something like this? Yeah, I think you could skip the new string and to char array thing here. Let's see. I did an inline update here, okay. Probably can do it now, I'm not sure when I wrote that code a couple of years ago whether what. Okay. Yeah, because it has the same targeting here, right? Assuming this works, I would say that it would, but yeah, I'm not sure. Pretty sure this wasn't actually possible in 2016, this way of writing it. So I don't know when you... Is there a timestamp here? 2 years ago. Yeah, you probably refactored that and didn't update the rest, I'd say. Because I think this wasn't, might not even be, I don't know when they added this. But makes sense. Could check the commit history, but it doesn't matter that much. Checksum, yeah. Yeah, this is basically the same logic. I just went way overboard and did a whole like compression thing. Let's see. The fixed walls are marked with a hash and doors are marked with a minus or this. Okay. The doors in your current room are either open or closed and locked based on the hexadecimal MD5 hash of a passcode. Your puzzle input followed by a sequence of uppercase characters representing the path you've taken so far. Oh my god. That's funny. That is funny. Yeah, thanks. This is very extra so far. Only the first 4 characters of the hash are used. They represent respectively the doors up, down, left and right from your current position. Any B, C, D, E or F means that the corresponding door is open. Okay. Any other character, any number or A means that the corresponding door is closed and locked. Okay. To access the vault, all you need to do is reach the bottom right room. Reaching this room opens the vault and all doors in the maze. For example, suppose the passcode is HIJKL. Initially, you have taken no steps, and so your path is empty. You simply find the MD5 hash of that alone. The first 4 characters these are CED9, which indicate that up is open, down is open, left is open, and right is closed. Because you start in the top left corner, there are no up or left doors to be opened, so the only choice is down. Next, having gone only one step, down or D, you find a hash of blah. This produces F2BC, which indicates that you can go back up, left, but that's a wall, or right. Going right means hashing blah 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 to get that. All those are closed and locked. However, going up instead is worthwhile. Even though it returns you to the room you started in, your path would then be DU, opening a different set of doors. Yeah. After going DU and then hashing that to get that, the only right door is open. After going DU, all doors locked. Fortunately, your actual passcode is not that. Okay. Passcodes actually used by Easter Bunny vaults do allow access to the vault if you know the right path. For example, if your passcode were blah, the shortest path would be that. Okay, given your vault passcode, what is the shortest path? Okay, this is pretty interesting because basically you could go up, down, up, down, up, down, up, down, and it would still be a valid path. So this is a pretty annoying one, I think. Because it's hard to limit the logic there. Because Lineberry says part 2 is especially fun. Okay. Like, implementing the basic logic is fine. It's not that hard. The only thing is, what kind of algorithm do you use to find the solution? Something tells me like you want the shortest distance, so. But since you can't really do any exclusion of path traversed, you can do pretty crazy stuff. Like this one It's interesting because yeah, I will write the basic step, and I'm not sure if I will finish this, but I will create a small part here, just because I'm intrigued now. Like the basic mechanics seem fine. I'm just very worried about the actual pathfinding algorithm and all the troubles that come from there. Actually, it's just a 4x4, right? 1, 2, 3, 1, 2, 3. Okay. So I don't think we need to even parse that. Let's just start with the simple one. So let's turn this into strings. That. Nightmare says, oh no, I confused this with another day. This is actually just a standard thing and rather boring. Okay, okay. I mean, I think that there's some fun parts in here, but yeah. Let's see. Let me see what I have for my grid thing here. Grid location. I think I had something with even like a function. Yeah, here. So I can do action like this. Grid location current is new 0, 0. And then I can do g.get walkable neighbors with direction current, and then I can do something like this. Sure. Okay, let's see. So we need to have the input string there. So you need to have like a queue, priority queue. And this would be string path, grid location, current pos, which is fine. this, q.enqueue, and we add input, trim, no, just input actually, and then we do current. Actually, I can just do like this. This needs to be enqueue, not enqueueDQ. Boom. So while q.count larger than 1, and we can do this. And here we can have the logic. So we do task is q.dq, task.current, pos, like that. Okay, so now we get every location and we have the logic here. So we need to hash that current one, md5 hash data like this. So this would be task.path plus actually we knew string new path is this is actually not useful this way, because then we need to do that. We can be, my thinking is I need that path actually to add it to the string, so calling this function here makes no sense. So I can just do for each var dir in again walkable neighbors, and now I can do dir dot location is the new path. Okay. This would be task.path plus dir switch. Is it a switch dir case? I don't remember the switch notation. Switch. Don't I have an inline one? I think it's like blah switch. Is it like string, and letter is task dot dir dot direction switch something like this. Oh, okay, never mind. Okay, so I can use this, name 0. That's fine. So string new path is task.path plus this. So string hash is md5.hash data encoding system text encoding get ASCII get bytes new path convert to hex string like this. Okay, and then we need 4 like this. That is not correct, because I just need to hash the current path. Yes, string hash is this, never mind. Task the path, and then I need to have a lookup for the index. So dictionary, this will be dir, and this will be int. Direction hash index. Okay, no. New. And then we have dir dot up is 0. It was up, down, left, right. Like this. Up, down, left, right. Okay, so that's the order. So this actually does become like this. And then we need to make sure we have to look up here, dictionary. Actually, we can just do a hash set, actually. Char. Door open, dir valid, actually, dir valid. So now we can do I think it was this one, right? B C D E F means open. Okay. It's actually like this, contains. So, okay. So this one will do the check there. This one will check if the path is valid or not. So if this one returns, then we can queue it up. So we can do queue.enqueue. And this would be task.path plus, and then this one. Where did I do that? This one here, yes. Does get walkable consider walking outside the grid? Yeah, not that. Yes, it does. It gets the bounds of the grid, and it will make sure that it doesn't let you go outside of it. Yes, yes. Thanks. I should just also add the value here, length. In this case, I could deduce it from path, but yeah. Actually, I could just do that, actually, never mind. Path input dot length, like this. Input is input dot trim. Let's make sure that we trim it. So we just add the path. This is dir dot location, and this becomes task.path.length plus 1, because we added 1 to it. Okay. And we should probably check if the end location, because it's a special one, this one will never work. Basically, this is our target path, 3.3. So we can do grid location, target path is like this. And there's no doors here, so if you get here, you're clear. So basically what we can do is if if dir dot location equals target path, return p1 equals path new path. Like this. Boom. Okay. So let's run this day and see if this works. I think it should do. Okay. Okay. Let me see if I did this correctly. Did I set it to test? Yes, okay. So I probably didn't. I need to make sure that I sequence of uppercase characters. Yeah, that's correct. The password. Up, down, left and right. For example, initially you have taken no steps. So your path is empty. You simply find the MD5 hash of that alone. The first 4 characters. Okay. Okay, so let me check the first one by hand, because obviously this ain't it. It did work in the end, which is funny. Okay, let's see. So we can go right according to the code. And we can go down. Okay. So it says it can go right and down. So down is open, left is open, right is closed. Okay, so what was the hash? CED9. Okay. Okay, let's run this again. Let me just check to make sure. Did I append something here? No. DE9F. Okay. Voila. Wait, HJKL. Did I use the wrong one? Okay. I mean, that's still not nice, but let me just see the first test. Wait, what? Okay, so this is a dead end, this one. Funny. CED9, okay. So there's only one. Cool, so this one exits because there is no valid path. So why did this one not work for me? So let me try the other one. It's so freaking long. I mean, I'm surprised that it finds something, but it's so very long. Could it be that my directions are my directions inversed, maybe inverted? Okay, let me see. Down goes to row 1. So no, that's not it. What the? other than this, I don't know. Really strange. I don't know. It's funny that it seems to find a path, but I don't know why it doesn't. Yeah, sure. Shoot, Nightberry. There's only one break, but 2 loops. Ah, I might. Thanks for that. Yeah, that looks more like it. Okay. If you see me do something stupid like that, feel free to just tell me next time. It could have been a while before I saw that one. Jesus. And the answer would actually be P1 is dot substring input dot length, like this. It's actually what I want. So thanks for that. Appreciate it. Let's see. DR. I think we got it. Yeah. Okay. So I can set this as the test. And now let's not do the test. That was fast. Woohoo! Gold star. Okay. Part 2. You're curious how robust this security solution really is, and so you decide to find longer and longer paths which still provide access to the vault. You remember that paths always end the first time they reach the bottom right room. That is, they can never pass through it, only end in it. For example, if your passcode were that, the longest path would be, okay. Sure. What's the length of the longest path that reaches the vault? Sure, okay. Ba-dum-bum-bum. Basically, I can just not do this. Actually, I basically did part 2 before I did part 1, so I can just do string path is now you just have to undo the fix, right? Yeah. Actually, I could just do this one here. And then do this. And then not care here. No, that's not true. I should be able to do this, right? No? Why doesn't it like this? Is that because it's still running? I can just do this. Boom, 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 and then I do longest length minus input length. No. Yeah, I need to undo that one. So now it becomes a DP issue? No? Would that be... You could do infinite loops, but... I could just do like longest length 566. It keeps finding longer ones, okay. So I guess I just have to wait. I wonder if it will exhaust at a certain point. Nope, it's still growing. 624. That's annoying. Should probably make some things. The longest path is not that long, below 1,000. It runs in no time for me. There must be some bug. Never underestimate my powers to make it stupid. Like if there's a path that just goes let's see, I think the task, the path. You can spot it, okay. It keeps adding here, yeah. Because I no longer have a break. That's my issue. $384, okay. Woohoo! We did it, okay. Thanks for the assist there, Nineberry. It's appreciated. Yeah, I forgot that the logic assumptions that you make because you introduce breaks at some points. You have to be careful when you alter your code. That's why you should probably never just alter your part 1 and just copy it and make a part 2 that accounts for it. Yeah. Okay. Yeah, that was fun. I think I'm gonna end it here and make sure that I don't get home too late today and get a bit of sleep, because it's been like, I think I've been going till past midnight every day. So yeah, I had fun. I hope you guys had fun as well. So let me just check Twitch if there's somebody we can raid and say hi to. Yeah, I'm gonna try to get some rest. Let's see. This dude is on every time. Let's see. If you have any suggestions, feel free to let me know. Otherwise, I think we're just gonna go say hi and check in again. I'm just gonna raid him again. Yeah, so thanks everybody. See you next week. And let's go say hi and check out what he's doing.
Today I'll leave a lurk. Appreciate the lurk, Sorcery. Have a great one. Thank you again for the raid. Enjoy. Alright, let's see.